Graphing with transformations. The trick to graphing with transformations is first of all to be able to identify the parent function or the parent graph. If we look at problem number 1, we see that we have x squared plus 4. Our parent function is the x squared function. And the basic x squared function has a shape that is a parabola, and it goes through the point 0, 0. If we look at problem number 2, our parent function is the absolute value function. And the absolute value function has a V shape, and its point is at the point 0, 0. So now the next thing that we want to do is to identify the transformation if there is one. If we look at problem number 1, we see that we have x squared plus 4, and that plus 4 is not grouped within the x term, so we call that an outside. And when it's outside like that, that means we're going to have a vertical transformation or a vertical shift. So the graph of that function x squared plus 4 is going to look almost exactly like our x squared function, except that we're going to shift it up by 4. So if we draw another set of axes down here, we're going to shift up 4 points, 1, 2, 3, 4, so right around there, and that's where our graph is going to be centered. And it's going to have the same basic shape as your x squared graph. Now you can find points to make it more accurate, but I'm just going to do a little sketch at this point. Let's look at problem number 2. Problem number 2, the basic function, the absolute value function, has a V-shaped, and so does its transformation. The fact that we have a minus 2 outside the x, so this is another outside. We're subtracting 2 means we're going to have a vertical shift, and it's going to go down 2. So looking at our new set of axes down here, we're going to go down 2, and we're going to redraw using the same basic shape. So the same basic shape as our parent graph, the absolute value function. And again, you can find points to make a more accurate drawing, but I'm just doing a sketch.